All right, so let's go ahead and take a look at this section. So, all right, we got a couple of product rules here. So y times the derivative of x to the fourth, which is 4x cubed, plus x to the fourth times y, which is 1 dy dx. That gives you the first one, minus y cubed times the derivative of x, which is 1, plus x times the derivative of y cubed, which is 3y squared dy dx. And this is all equal to 0. So 4x cubed y plus x to the fourth dy dx minus y cubed minus 3xy squared dy dx is equal to 0. So x to the fourth dy dx minus 3xy squared dy dx is equal to y cubed minus 4x cubed y. So then dy dx times x to the fourth minus 3xy squared is equal to y cubed minus 4x cubed y. So then dy dx is equal to y cubed minus 4x cubed y over x to the fourth minus 3xy squared. And then I wanted to plug in negative 1. So that gives me negative 1 cubed minus 4 times negative 1 cubed times negative 1 over negative 1 to the fourth minus 3 times negative 1 times negative 1 squared. That's a lot of negative 1s. Minus 1 plus minus 4 over 1 plus 3, which is negative 5 over 4. All right, this one here. So derivative of tangent is secant squared, x, y. Okay, times by the derivative of x times y, which is y times the derivative of x plus x times the derivative of y is equal to derivative of y dy dx. So y secant squared xy plus x secant squared xy dy dx is equal to dy dx. Okay, so then x secant squared xy dy dx minus dy dx is equal to negative y secant squared xy. All right, so now dy dx times x secant squared xy minus 1 is equal to negative y secant squared xy. So then dy dx is equal to negative y secant squared of xy over x secant squared xy minus 1. So dy dx is equal to negative 1 secant squared of pi over 4 divided by pi over 4 times secant squared of pi over 4 and then minus 1. So pi over 4. So sine, so if I have 45 degrees, 1 root 2, so then it is 1 over root 2. So then that's root 2 over 1 is secant squared. So then this gives me a negative root 2 squared pi over 4 root 2 squared minus 1. So then this gives me a negative 2 in the top. This gives me 1/2 pi on the bottom minus 1. Or pi over 2, as it may be. All right, and that is it for this section.